Okay, so first of all, let me introduce myself. My name is David Payne, and I am the director and head coach at Youth Coding and Innovation Club. And I have been teach maybe more than 100 different kids, multiple different class in the last couple of years. And it's really excited to teach a lot of kids. And when they really learn something new, they're really excited to find something which they have interest. But sometimes they also struggle to understand some of this basic concept. So this event is not really about the coding itself. Instead, it's really an introduction. Okay, it's really try to give you a basic idea about what's really the artificial intelligence it is. And if you have never really know this before, you probably get the basic idea. And let me share my screen first so we can save some time and try to start quickly. Okay, since my screen is on this side, so I just try to face this side. Okay, a very quick question is that if you don't feel comfortable to answer the question, you can also put the chat, but I strongly encourage you to really speak out wherever you can. And so the first question is that, what's the smart device or any kind of smart, like smartphone or smart TV or any kind of smart device you have in your home? Anybody can tell me at least one of the?
Google.
Google, that's great. Okay, any other device you have?
Siri.
Siri, yeah, that's right. And
Alexa.
Alexa, oh, that's very cool. Looks like everything is about the voice. Okay, anything other than the voice? I know it's a little bit challenging.
Computer. An
computer, iPad, yeah.
Corner.
Okay, that's right. So basically, we have a lot of smart device. We call it smart device, but actually, you can think about that. It's really something. Oh, Tiger, are you able to try to help me to admit all of this?
I've been doing it for
okay,
a while.
Great. Yeah, because sometimes I not really keep it on time. So, okay. So the really idea about the what's so-called smart device is really have some kind of intelligence built in, like the Google Assistant or Alexa, right? So like I speak to my son, Tiger happens to be my son, and sometimes he don't really understand the Chinese. And sometimes I don't really understand his word in English. So he will ask Google. We have both Alexa and Google in home. So he will ask some question to Google. Tiger, can you show them what kind of question you ask Google?
I don't have a device in my room right now, but
It doesn't matter. Yeah,
normally I would just say like, how do you say croissant in Chinese or something? And then Google will respond and I'll be like, and then my parents will be like, oh yeah, that word.
That's right. Yeah, it's really smart, right? So Google don't really know who you are, and the Google don't really know what's your background, but Google do try to understand what you are speaking. So that's really how the voice regulation works, and it's really something as a very basic as a smart device we use. So anybody can recognize this one? This is a very cute robot from a movie. I'm not quite sure which movie this is, but anyway, I remember this is from some kind of old movie. And if you see this movie, really can talk and they can think, and sometimes they have emotion and they can make the decision, right? So it's really very cool, but how they get the intelligence, it's really a question. So this brings up to the concept about what's really the artificial intelligence is. So the definition here, it's really kind of boring, but the very straightforward answer I hope you guys can give to me is that, how do you think the AI is? Anybody can give me a hint? Robert, okay, what, okay. So it's really about the intelligence, right? So what's really intelligence here is try to think like the human and behave like human. For example, if they try to understand what you speak, like Alexa and the Google Assistant, all of what they do is try to behave like humans. Say, okay, when I speak something, you can understand. But when you speak to Alexa, they try to understand what you are speaking, right? But beyond that, they also have something. If you see the smart camera, they can detect your face, and they try to identify who you are. I believe some of your home may install the smart lock or smart camera at the front entry, so you can register your face, and they can do the facial recognition. And so you don't have to have the key. You can get in and out. Okay, that's something really what we call the artificial intelligence. So all this device or machine try to do is that they try to do something thinking like the humans thinking, right? Okay, so we have a lot of examples. I just list a couple of them here. Something like self-driving car. And anybody know what's Boston Dynamics? Okay. Yeah, if you know what's the Boston Dynamics, it's really, really cool. It's a super cool robot. And if I have chance, I can show you some video here, but I'm afraid we don't have enough time. But let me try to Google. Okay, Boston Dynamic.
Did you use the remote again?
Robot. Okay, cool video. Okay, so something short. You probably cannot hear it. Let me try to share this one. Oh. Okay. Okay, we don't have time to play the whole full length of the video, but I give you the basic idea. That is the robot based on the AI was so advanced, they can do a lot of amazing stuff. And we don't even realize how much they can do. But basically, that's just some sort of advanced AI. But we have some other AI which is not really necessary to be so advanced, like the chatbot. So the chatbot is really something, if you speak to Siri, right? So they can answer your question. Sometimes you have fun with them. They can give you some of this ridiculous answer. But this is some sort of the AI built in with the chatbot. We also have a lot of game. If you play the game, you probably don't even realize how much intelligence they have, but they do. A lot of this game nowadays they build with very advanced algorithm. So they try to understand your behavior. They are not really only like the games they used to build. They have the very preset pattern. Now they can build some pattern on the fly. So that means they can build the new game, not really totally new, some sort of new game based on your behavior. Okay. And here it comes with a couple of really interesting concept. For AI, of course, this is really a buzzword, and you probably heard a lot. But before we really understand what's really the AI, they have something you probably never heard before, at least at your age. One is called the weak AI, another one is called strong AI. So you just think about what's really the weak AI is. The weak AI, it's really think like that. If you consider the Alexa or the Google Assistant, they are really the weak AI. The whole reason it's not really because they are not strong enough. They are very good on certain field, but on the other hand, they're still not really able to think for themselves. So that means they are constantly try to make the response for some specific situation, even it's really the language based, but they are not really think like the human. Okay, and on the other hand, what's a strong AI means? The strong AI, it's really you can think and act like a human. Okay, this is a very quick question. Anybody know who this guy is? This picture?
Einstein.
Einstein. Okay, cool.
Albert Einstein.
Okay.
Albert Einstein.
He was considered one of the smartest human being. Of course, may not be by IQ, but he's really super smart. So the whole purpose of the strong AI is try to build some kind of a computer or device, whatever you can call it, to be another Einstein. So they can think like Einstein, they can behave like Einstein. So it's really, they can learn by the experience. So that means they continue learning. That's why when we are heard the term about the AI, we also a lot of times heard another term, that's this term called machine learning. Okay, since you probably it's really the elementary school student, so you definitely heard some term before, but you don't really know what's the difference between them. Basically, you can think like the umbrella, right? So the AI is really a term which you can cover a lot of different corners. But on the same time, the machine learning, it's really some subset or some kind of AI, which they can continue learn and improve without really the help from the human or new program. What that really means? So just like you think about that, if you have your younger brother or younger sisters in home, they are age 5 or younger. So do you try to observe how they learn and how they adapt, right? So when we are baby, we have no idea about this world, what we are doing. So every day we are learning something, right? So like we are cry, baby cry, not I am cry. The baby will cry for what? They send the alert to parents, right? So the parents will realize, oh, there must be something wrong. So it's really some sort of intelligence the baby start to build. And when they get some basic knowledge, they try to train themselves. So that's how the human brain was grow. If you're thinking about that, a lot of times, if you have pets in home, some of these pets like the golden retriever, the dog, it's a very nice dog. They say, oh, this dog has intelligence the same as a 4 years old kid. What that really means? So that means that dog really have some kind of intelligence, but they are not as smart as the people, right? But at the same time, the dog is really continue learning something. So that means the machine learning, the whole concept is, okay, it's not really you tell them how to do it. Instead, you just give them the chance, you train them, they will learn something new, just like the baby. Okay, so you don't have to worry too much about why you cannot do the machine learning by yourself, because this is super challenge at this time yet for your age. So it comes out with a very famous theory, which is called Turing test. Okay, anybody know this term, or anybody have the basic idea about what this really refer to? Okay. Okay, so I give you a basic idea. The whole point for this test was really raised by a very famous scientist. He was considered as a pioneer or one of the earlier creator of the modern computer. His name is Alan Turing, and Turing has some sort of the hypothesis, say, if you cannot detect whether it is a computer or it is a human when the response back to you, that means they are really become so smart. And it's really something which break the barrier. So that means, for example, in this picture, right? So you can see this is really for example, you are working for CIA. You try to try to find out whether he's a spy, and he will answer your question. You can ask him a lot of different questions. At the same time, there's another computer. He can also answer your question. If the computer can really act or behave the same or even better than this human, so that really means this computer have the intelligence. So it's really a very straightforward answer, but it's very hard to achieve. Since 1950, we take more than 50 years, we still not really able to fully achieve this, because this is super hard. But this is something probably you heard before. If you don't heard, try to remember this boss term, and next time you can ask your friend, maybe they will really surprised, say, gee, how can you know that, right? Okay, so now we go back to what the human really good at, but the computer is not good. If you're thinking about computer don't really understand your language. Computer cannot really identify your face. They cannot really identify which object it really belongs to which category. So what really computer try to do is we build the computer and we try to make the computer think like the human. So this comes with a term, again, you probably never heard this before. It's called computational thinking. Computational thinking, it's really something, it's not super challenge. If you think about that, it's really try to say, you have a problem. So how can you decompose? So say you break down this problem and then you try to find the pattern. Of course, first you probably need to create some kind of abstraction. So that means some sort of stuff which you can understand. All of this term, again, if it's too challenging for you, you do not have to really understand that. You're just thinking about how we as a human solve the problem, right? I give you a quick example. When you go out and you see a dog, how can you know that's a dog? It's not a cat, right? Or you see there's a dog walk with your friend. Of course, you can identify who is the human, who is the dog. But if you give the picture to computer, can computer understand that? So how, if computer can understand that image, how can they do it? Why they can really identify who is the human, who is the dog, right? So all of this is come from the very beginning. They try to decompose the problem. So that means they try to slice down, say, okay, there are two different objects. One is like a human, another is like a dog. They don't really know whether it's dog or human. And then they try to do some sort of the regression. They try to sort through the pattern. Of course, they build the algorithm in the end, right? So we try to build the computer to use the computational thinking, and then they can solve the problem for us. That's very, very important. If you have ever learned any of this computer programming, even use a Scratch, the simplest program will ask you to do something very fundamentally you probably never touched before. So you need to think about, oh, what's this first step? What's the next second step? And how do they work together, right? Okay, so this is how humans do. And then we will ask the computer doing this. Okay, so for example, the CPR means some kind of assistant if you see somebody have the emergency, right? So how can you do it? You probably will call 911 first, and then of course you try to give the assistant, and you will check to see if they are brief or not brief. If they are not brief, you will give them the chest compression and this part. Try to help them to breathe. And if they still do not able to, okay, it's not silly. You have to save the life. So you will do this step, right? And in the end, you may heard the ambulance coming over, say, oh, it's really coming. That's great. So in between this 911 call and the ambulance coming, you will do this step to save this guy's life. So that's really how we break down the step. So we are training ourselves when you go through the CPR training, we training ourselves go through that step. So do the computer. The computer, they don't really know how to do it. So they will go through the same thing. That's how we are referred to as computational thinking. Okay, so this is something we call the flow of execution. So you can think about that from the start, you will check certain condition. So this condition maybe is here. So you will check, oh, if this guy still have breath or not. If not, I have to help him. So I do the chest compression for him. And if still not work, I will do some rescue breath. Okay, so this is some sort of decision make. So you have to check the condition and then you do the next step. So this is, I don't really give you too much of these details. It's because they are overwhelming. So you probably get confused by that. But the basic idea is that ask or make sure the computer will able to understand step by step. So break the big action into the small step. So to here, we can find the square root of a number. And then how can we do this is that we ask them to enter a number, for example, 5, for example, 16. Okay, so if the number is larger than 0, we go to the next step to make the calculation. And after we get the answer, we can display them, something like that. If you ever really make any kind of programming, you probably understand this step. Otherwise, just thinking about that, we try to break this, find square root of a number into multiple steps. So that's what we try to do. Okay, so this is a very quick coding example. We will not really go through that because this one don't really have anything to do with our topic. That's about AI, but you probably find it's very helpful if you can understand that. Okay. Of course, this is how their running looks like, but again, we have limited time, so I don't really go through that. So now we are thinking about how can we use the computational thinking to enhance the game with the video sensing. Of course, the video sensing is some kind of new feature for the Scratch 3. Anybody here have never really used Scratch before? You can watch how Tiger give you the demonstration of that. But again, you do not have to fully understand that if you have trouble about that part. this is really some sort of block about sensing. Sensing, just like our human have different sensing, right? Okay, here is the quiz again. Anybody can give me the name of different sensing for the human?
The mouse.
Mouse, yes. So you can taste, right? Any other answer?
The
Other sense?
nose.
The nose, that's great. You can smell.
The ear.
The ear, you can hear.
The five senses. Eyesight. The eyes. Eyes.
Okay,
What?
eyes, yes.
What?
Okay, somebody have to mute. It has the echo.
Echo.
Okay. Yeah, that's great. So we have the all of this sense. We call it this sensing system, but for computer, they also have the sense, right? So how do computer have the sense? It's really comes with different sensor and different device. For example, we have the camera here, so they can really detect the face here. And we also have the microphone, so they can detect what we are speak. Okay, so now let's ask Tiger to give us a quick demonstration of the program. And I think we can skip this program because this is a very basic one. And we direct go to the video sensing extension and the program of how to use it. Just in case you have the Scratch 3 account, you can play around with Tiger, and Tiger will show you how the video sensing works. Tiger?
All right, should I share my screen for this?
Yes.
Okay.
Let me stop sharing and you can share your screen.
All right, so, okay, this is the right one. So we are down here. Okay,
Yes.
so video sensing is like a special extension, as my dad mentioned, for Scratch 3. And it just uses your computer's webcam or any other external webcam that you have attached to detect motion or detect color or any sort of visual thing like that. And it's really cool because you can make simple games and interact with your characters in the computer using motion in the camera that it detects. And the way you install that, if you have a Scratch 3 account, and if you do, I'll give you like a minute to open that. Just wait a tiny bit. If anyone does. Does song need to be omitted?
Yes, actually you can follow along and try to play the same game as what Tiger did here. It's a very short application, so I'm almost sure you can really finish that here if you want.
All right, so the first step is to install all the different modules, which is done with this little button in the lower left corner here, which allows you to install all the extensions. And the three that you'll need are the music extension, the pen extension, nice little rainbow there, and the video sensing extension right there. And those are the icons there. All right. And the foremost, wait, is everyone caught up? Someone, if you want to tell me to slow down or stop or whatever, just unmute yourself and tell me. And the four most important blocks for the video sensing extension are the hat block, which allows you to activate a piece of code when a certain amount of motion is detected in the camera. I don't know why the camera's not showing up. It usually shows up on the right side of the screen where the cat is, but I guess we'll see. Oh, there it is. Backdrops, code. Yeah, it's the hat. Okay, never mind.
Turn your video on. You have to see the. It says to turn video on.
Where's that?
It's okay, you can continue.
Okay.
I think he asked you to turn on the camera. I think you already turned.
Yeah. And the second block is a variable block, which allows you to set the motion on either the background or on a specific sprite over the location of a specific sprite as a variable. So that'll be like a number that the camera determines to be the amount of motion, like how fast you're moving, how much change there is, how crazy it is. And that'll be the variable that you can set there. And the third block is a block that allows you to turn the camera on and off. So if you want to display that camera on this right side of the screen over here, you can turn that on or off. And the fourth block is one that allows you to change the video transparency, which is like how much you can see through the background or the sprites or anything like that, how much you can see your face through all of that. And 100 means you can't see it at all. And 0 means that you can see it completely. All right. Let's go into a simple example. And this simple example is just to demonstrate the fact that the camera can actually detect the motion that's going on. So first, it'll turn the video on. It'll play a sound to confirm that it turned the video on. And then when you move, it'll make the screen go completely white, and it'll slowly make it more transparent until you can see yourself again. When I was experimenting with this, I kind of thought of it like hiding from a T-Rex, like they can only see you when you're moving. So if you move enough, the screen will go completely white. So your goal is to not move at all. Let's try to see if we can do this. So you can just follow along with this set of blocks here. I'll do it for you on my screen. Just throw those away real quick. Turn the video off. Play sound meow, which I'm pretty sure is a default sound that we have, or not. Oh, might be a sound of the Scratch Cat sprite. Yeah, play sound meow. Okay. Turn the video off, and then wait a couple of seconds. And then afterwards, you have to try to stay as still as possible. And here we have a variable that we're going to use to control the transparency of the camera, which, as I said before, is how much like you can see through the background into the camera. We're just going to go to the variables, the dark orange tab, and click make a variable and set it to transparency. We're going to manipulate that with these blocks, which is set variable transparency to 100, which means you start out completely not being able to see the camera at all. And then you have a quick block. So just to go over what's happening so far, it's saying when the camera detects a certain amount of motion greater than this, you first turn the video off, and then you play the meow sound. Then you wait 2 seconds, turn the video back on, and then make the screen completely white. And then in this next loop here, which is just going to repeat 10 times the contents of this block, you change, oh, that's not what happens. You take the variable transparency that you said before, and you use it to control the actual video transparency. And then every loop, you change the transparency by -10, which means you're making yourself slightly more visible at every loop. And just so it doesn't happen too fast, you put some weights in there. Like that. Does this work? It worked when I was testing it earlier. Do you have any clues on why this doesn't work, Dad?
Let me see. This one?
Add when what arrow clicked or like what click moved.
I think I figured it out.
Do you check the?
Did I figure it out? Did I check what, Dad?
No, do you check your camera if the camera is able to be detected?
How do I check that?
You can play you can display whatever the variable is, and then they can show you, oh, this should already start.
Yeah, but the camera's not showing for whatever reason.
Do you click that flag? Yeah, you stop and then click that stop and click the start again.
I don't think anything's happening.
Yeah, you probably need to check what the transparency level currently is.
It shows up. You can see that little counter there.
They never change?
It changed once, but this was working when I was testing it earlier.
You don't have the loop. You need to go through the loop, right?
Look.
Yeah, you have to repeat 10 times that loop.
Yeah, repeat 10 times. Oh, well. Right, sorry. I copied the code wrong.
Yeah.
All right, so I'm going to do it correctly this time, and just inside this loop where you do it every 10 times, you change the video transparency.
Yeah.
And then you increase the transparency slightly every time until you can see yourself again. Except it doesn't work.
I mean, I did hear the meow.
I'm glad that works.
Yeah.
Wait, what? I thought I copied this code over.
Do you upload the code what I just sent to you? Maybe you can.
Yeah, it was the correct code.
Okay. Share and then until it's done, wait, turn off, set transparency. Oh, you need to change. Oh, you already changed. Change that. Set detect. Oh, you need to set detect, not transparency. You need to detect. Set the detection to video motion on stage.
Ah. Oh.
Yeah, you don't really do that. Not exactly the same.
I don't see why that would make it break though. Video motion on stage.
Yeah, they need to detect what you're really on the stage.
Doesn't seem like it's going to change anything.
Is that working?
It doesn't seem like it. Yep, nope.
You can change that pen to be different value. Let me see if there are anything different.
Oh, wait, I'm an idiot.
Yeah.
Not that it still doesn't work.
Okay, don't worry too much about that. I will share the program and just make sure they are really working on my side because we have some other stuff to cover. So
yeah,
at the same time, you can try it silently. If you make sure it's working for you, we can come back. Okay, that's okay. So one thing we learned here is that nothing is super simple, right? So even we try to make something happen, it's probably sometimes it didn't work. That's okay. It's part of the programming. So when we are doing some programming, sometimes it works fine, sometimes it didn't. So it's most likely somewhere has falling apart. So that's part of our life. Okay, so let's skip this project and then we go to.
I can't see the code.
No,
we
don't really share the code anymore. So I'm sorry. Yeah, this is about another subject. So now we are talking about how to identify the image, like the question what I bring up. If you still remember what the question I asked, when you see your friend walk with his dog, so how can you identify who is a human, who is a dog? Or even more than that, if your friend happens to have both a dog and a cat, how can you identify who is a human, who is a dog, who is a cat? Anybody can give me a guess or give me some sort of answer
By
The
look.
way they look.
by how it looks like, right? Yeah, so
By
that's
using the senses.
by using the sensors. Okay, so really what we try to do is that we have, of course, the human eye can really detect the picture. So do the video camera, right? So they can really see whether this is a cat, this is a dog, but we can identify far more than that. So we can identify whether this is car and this is cops, right? So it's really something very fundamental. It's not really some magic for us because our human was trained to identify the image since we are really young, like the baby. Do you think the baby know who is the dog, who is the cat? I don't think so, right? So the mom or dad would tell the baby, say, oh, this is a cute cat. Okay, so the baby will try to remember, okay, this animal, it's really a cat because my mom or my dad told me. And next time your dad may tell you, oh, see, that's a really nice and cute dog. So you try to identify, see whether this is a dog, right? So how they really work together is that we trained our brain try to categorize the image into different sort of animal. I just talking about animal here. Of course, we can identify millions of different kind of stuff. Okay, so what we are really doing here is that we break it down into steps. So thinking about the computational thinking, right? So how can we break down into steps? So the very first is that you have a lot of picture. For example, on the left group are all cats, right? So you go through just thinking about if you are a baby, you see each one of this, and somebody just tell you that's a cat, that's a cat, that's a cat, that's a cat. So every time you see this picture,
Stop.
you are train your brain one more time. Just say this is a cat, right? On the same time, if you see the dog on the right side, you see a lot of dog. So
Shut
every
up.
time you see different kind of dog, somebody tell you, okay, this is a dog and that's another dog. Oh, this black one is also a dog, right? So you try to really give them something called tag. So we give them the tag, say, okay, on the left side, this tag for this animal is cat. On the right side, the tag for this animal is dog, right? So that's why we need to give the image a tag. Believe me, the human, it's really built that in our brain, but if we want to train the computer, it takes a lot of computer power to really keep track of this and understand it. Okay, so after the first step is that we found lots of picture, we give them different tag. And then the second step is we need to train the AI. I use the AI here. You can think about any sort of device or computer or software, something. Software combined with hardware. So you have to train them. You have multiple picture, just like you train the baby to identify the items, right? So if you have a younger brother, younger sister, he or she is really so young. He don't really know a lot of dog. He maybe see one or twice of the cat. So he probably still get confused with a very cute dog and identify it as a cat. It's possible, but we as a human continue to train our brain. So do here, the computer system can continue to train the AI system, how to identify them and categorize them into different animal group, right? So this is second step. After the target, they try to train. Okay, so let's see what's the third step. Yeah, this is really the step we already have enough knowledge. So now we can learn and identify which animal it belongs to which category. For example, you give the picture of the cat. What they are doing is that they try to go through multiple steps and they try to understand, oh, this may looks like an animal first. And then say, this animal, it's some sort of small animal, not really like elephant or a tiger. And then they go through another step, say, okay, now it's probably the animal either it's a cat or it's a dog. Then they have, I just make it up. The final step say, okay, I figured out this one is really a cat. Okay, so you understand they are not really able to direct jump from here to here. Instead, they have to go through multiple steps. Of course, I don't really give you all of these details, but you can think about that. The whole AI system was what we call trained to able to make the, officially it's called image classification, but you can also think how to identify different animal. Okay, so I give you some quick example here. If you haven't able to see this, you can follow with me and do the same thing. Okay, let me see if this is working or not. Looks like it stopped working, but anyway, I try to restart it. Okay, so this is come from Google, and it's a very nice program which you can drag your image file here, and then they can identify and find out what kind of object it's. Oh, say even it's an animal or it's a human or it's some sort of the object like the cars. Okay, let me drag and drop a couple of picture over here. I drag a simple picture here first. It's a cat. Okay, you have to tell them I'm not a robot, so they know you are not really try to attack the system. Okay, so what you can get from here is that they tell you it's 98% of the chance this is a cat. Okay, and see the label. They have the skin. It's a small to medium-sized cat. And what this means, I don't really fully understand. Tiger, do you know what this means?
It's the genus of the species, I think. It's just
Okay, this
classification.
is the species. Okay, that's very cool. And
Cat thing, tigers, lions.
okay, and they also tell you what's color, so it's orange color, some sort of that. Okay, so they give you a lot of information. And if you see, sometimes they give you the information says 51%. So that means they are not 100% sure whether they show you toe, but they do, right? Okay, and of course you can also check the property, something like this. What's a different ratio? And safe search. That's different. Okay, I don't return on that. Now let's reset and try one more. Just in case you are not really able to direct go into here, maybe you have to ask your parents to set up this. I believe any of this Gmail account can go to access it without any problem. Otherwise, because this uses what's so-called Google Cloud Vision API. So you just go to this and you can play with me. At the same time, you probably can find something. Okay, so just in case you don't really know where I get this picture, I show you one more time. Okay, so
Jack, Google.
go to Google and then you can find picture, right? So let me say, a man walk with dog. Okay, so this is the question what we try to get, right? So you Google and search the image. Okay, so that's very cool. I've used a simple image first. Okay, so this is the man walk with a dog, and I save this. Go to my man walk with dog. Okay. Okay, so I have this one, and then
Time we can go.
I try to upload this. Okay, you just drag this picture over here. Okay, see? So now they give you something like the answer here. Say joy. Oh, say this human is really happy. That's really very cool, right? And then you can see what kind of object they can detect. They can detect the pen, 96%. And they say 91% is a human, is a person. And they even find it has a luggage and bag. Of course, they can find an animal. I'm not quite sure why they don't just say this is a dog. Probably they're not really fully understand that. But they do able to find, this guy has a shoe and they have the top and they have different kind of, oh, they do find the dog. That's my bad, okay. So they do have a lot of different label, okay. So that's a very interesting concept about how they can understand it. And I give you one more thing, which is quite interesting, is that I believe, okay, I drag this picture. This picture is a human with different kind of emotion, right? Okay, so you can see here, this guy have, okay, here. This is a person, of course, it's six person, but it's the same person with different face, right? And they have different labels. So they have the ear, they have the lips, they have cheeks, and they are really able to, okay, I believe it's here. It's here, okay. So they are really able to tell you whether different face have different emotion. So the first one, they said, is the confidence. Okay, maybe I should show you the picture on the side so you can compare them. Okay, so you can see the first picture, they say, oh gee, let's get out here. The first picture, they said it's really confidence, right? So, this looks confident. And the second picture, they say, it still have some sort of confidence, but looks like they are really angry. Okay. And then the third picture, oh, I'm sorry. The confidence level, it's not really say confidence, but they do tell you very likely or unlikely. So this means unlikely is angry, and this is very likely is angry. But anyway, they don't really show you why they are not able to detect some other stuff. But that's give you the basic idea. Give you one more step, one more stuff to try it here. You can try to play around with me because this is very cool. Okay, sorry, I cannot.
What
Okay,
if?
so this is a classroom picture. So in this classroom, and you can find the object. So you can see each of this square. So this student, teacher, and student again, right? So they find different person. So they find a lot of person. And then they have the label of, this is really find the arm, right? And this is a room and it's a class. So they are very confident to tell you, it's really something we found. We have found the table and we found the furniture and it's learning, it's in school, and they found the chair, teacher, sharing, right? Okay, so all of these are really so cool, and you can play around with this. If you don't be able to access it, you can ask your parents to do it. Okay, so the last one is something I want to share with you. Was built by IBM engineer. If you go to this website called the Machine Learning for Kids.co.uk, I have one account created for that, but just in case you don't have the account, sorry. This one. Machine learning. No. Oh, it's here. Okay, sorry. Just in case you don't have an account, you can register an account. So basically, this site is built some sort of extension for Scratch 3. I show you very quickly. Since this one not always work, so I cannot guarantee it will work this time. So I have the project, cat and dog. Sometimes it didn't work. It's not really as good as Google API can do, but I just give you the basic concept. So if you go to this project, the breakdown into 3 steps. So the train and learn and test and make. Okay, so you can train them, use different picture. So now I have a lot of picture. I have the cat picture, right? So this is all labeled as cat. And I have dog picture. It's all labeled as dog. And I also have the picture as a fish. So if you want, you can add new label, but you don't have to. And what this tool is really nice is that you can open another browser and drag the picture from another browser just right over here. For example, I want to show the picture of fish. Okay, so I go to here. I found an ugly fish. I just drag over here. See? So I add a picture of fish over here. I'm sorry. Why it's maximized? Okay, so I can add one more if I want. The fish not really looks very nice for me, but okay, this is a nice fish. Okay, I drag this fish over here, right? Okay, and then I want to train them with different kind of dog. So I just say, okay, I want to train the dog and I want a different kind of dog picture. Okay, this is a nice and cute dog, but anyway, that dog is, okay, this one. I drag this picture over here and, oh, that's a nice dog, but this probably hard to understand. Okay, this sad. Okay, I drag over here. So you can see the dog, fish, and just add one more cat, just in case you like the cat. Okay, I drag this cat over here. Okay, so now we have different kind of animal was break down into cat, dog, and fish. We go back and we can ask them to train. So now let's say, oh, you have 23 different kind of cat, 24 different kind of dog, 17 of fish. Now you can train them. Why they don't show me the train? Okay, so this is the model they already did. I remember they have one place they can train. You can use this web camera to test, or you can draw it to test. But that's what we are not have time to do it today. We go back to the project. So you can direct go on to the project. They have some sort of the new block which can recognize the image. So I have built up some project here. So just in case you are not really fully understand that, I show you a demo. Okay, so this is try to identify the carp and the cost. So let's run it. Okay, so it's not really always work very well, and sometimes it did, sometimes it not. So I just give you a quick introduction of that.
Yeah, ready for this.
Okay, so that's pretty much what they're doing. They try to sort it out, and okay, I break this up, and then I go back to here, and I run this again. So this try to sort the different dog or cat. Okay, this not really has been tested very carefully, so that's why it's not really looks very nice. But you get the basic idea. They try to figure out whether this is a dog or this is a cat. I will share all of this video to you, and you probably like to play with this one first, because this Google Vision API is really cool. They give you a lot of idea about how
No more chat.
And chat is still here. So that's pretty much it. I try to control the time very carefully. It's 7:01. So the last part is a Q&A section. Anybody have any question or any suggestion about this seminar? or in general, how do you think about the coding? Or do you like coding? Or you have never coded anything? Or you have some kind of struggle? Just let us know.
I do Scratch
You do Scratch. That's great.
every day.
Can you explain you said something, you said there was like a test that Alan created to test computers. Can you explain that part again? I didn't really.
I'm a Scratcher too.
Okay, so you are talking about
The like Alan Turing test.
this. Oh, Alan Turing. Okay, that's very cool. That's a very good question. Okay, let's give you the Turing test. Okay, I hope I can find a Turing test YouTube video. YouTube video. Let me see if I have a short one. Oh, this is very cool. I hope I can share the audio. Let me see if I can share. Let me see. Just give me 1 minute. I stop sharing and then I can share that. Share. Advanced sharing. Okay.
Yeah, last time I didn't hear your audio too. Like it was like
Yeah, I try to share with the audio. That's what I try to do because otherwise it's really hard, right? So
yeah, try going to settings and device audio, I think.
okay. Try to go to the setting. Okay, wait a minute. Let me see. Where's my setting here? Just give me 1 minute. Okay. Live on YouTube. No, not here. Okay. Just give me 1 minute. I have an idea. I can play this. This probably have some kind of echo, but I will figure it out. Okay, I will share this screen and oh, why I cannot share this one here? Wait a minute. Share the screen. Yeah, it's here. Okay, I can share this one. I definitely believe this will work. Just let me know if you cannot hear it. Okay. Can you hear it?
No.
No? Okay. Sorry. That's my bad.
Oh, I hear some noise now. No, I don't.
From here, then I can play use speaker.
I can't even hear anything.
Sharing. Just give me 1 minute.
Can't hear.
Can you hear it?
Yeah.
Heard you. Oh, I could hear the ad. Like when the ad was playing, I could.
I can't hear it.
Yeah, the
What is consciousness?
Hey.
Can an artificial machine really think? Does the mind just consist of neurons in the brain, or is there some intangible spark at its core? For many, these have been vital considerations for the future of artificial intelligence. But British computer scientist Alan Turing decided to disregard all these questions in favor of a much simpler one. Can a computer talk like a human? This question led to an idea for measuring artificial intelligence that would famously come to be known as the Turing test. In the 1950 paper, Computing Machinery and Intelligence, Turing proposed the following game. A human judge has a text conversation with unseen players and evaluates their responses. To pass the test, a computer must be able to replace one of the players without substantially changing the results. In other words, a computer would be considered intelligent if its conversation couldn't be easily distinguished from a human's. Turing predicted that by the year 2000, machines with 100 megabytes of memory would be able to easily pass his test. But he may have jumped the gun. Even though today's computers have far more memory than that, few have succeeded, and those that have done well focus more on finding clever ways to fool judges than using overwhelming computing power. Though it was never subjected to a real test, the first program with some claim to success was called ELIZA. With only a fairly short and simple script, it managed to mislead many people by mimicking a psychologist, encouraging them to talk more and reflecting their own questions back at them. Another early script, Perry, took the opposite approach by imitating a paranoid schizophrenic who kept steering the conversation back to his own pre-programmed obsessions. Their success in fooling people highlighted one weakness of the test. Humans regularly attribute intelligence to a whole range of things that are not actually intelligent. Nonetheless, annual competitions like the Loebner Prize have made the test more formal, with judges knowing ahead of time that some of their conversation partners are machines. But while the quality has improved, many chatbot programmers have used similar strategies to ELIZA and Perry. 1997's winner, Catherine, could carry on amazingly focused and intelligent conversation, but mostly if the judge wanted to talk about Bill Clinton. And the more recent winner, Eugene Gustman, was given the persona of a 13-year-old Ukrainian boy, so judges interpreted its non sequiturs and awkward grammar as language and culture barriers. Meanwhile, other programs like Cleverbot have taken a different approach by statistically analyzing huge databases of real conversations to determine the best responses. Some also store memories of previous conversations in order to improve over time. But while Cleverbot's individual responses can sound incredibly human, its lack of a consistent personality and inability to deal with brand new topics are a dead giveaway. Who in Turing's day could have predicted that today's computers would be able to pilot spacecraft, perform delicate surgeries, and solve massive equations, but still struggle with the most basic small talk? Human language turns out to be an amazingly complex phenomenon that can't be captured by even the largest dictionary. Chatbots can be baffled by simple pauses like, or questions with no correct answer. And a simple conversational sentence like, I took the juice out of the fridge and gave it to him, but forgot to check the date, requires a wealth of underlying knowledge and intuition to parse. It turns out that simulating a human conversation takes more than just increasing memory and processing power. And as we get closer to Turing's goal, we may have to deal with all those big questions about consciousness after all.
Okay. So that's pretty much it. And yeah, I sent in the chat box, anybody want to get a certificate of participation of this event, please ask your parents to contact me either through email or through WeChat. And yeah, I'm really excited to see your participation. And I know it's 1 hour and 10 minutes, and it's a lot of information. A lot of this boss term probably is the first time you ever heard, but I do believe you have the chance to learn more in your future. So anyway, if you have any suggestions or you want to participate some of the future event like contest, you can ask your parents to contact me. And again, I hope you really understand something now and have more interesting about the AI. And in the future, no matter whether you are doing engineering job or just some other job, it's good for you to understand some of this basic idea. So again, you have a good night, and I will see you guys in the future. Thank you. Bye.
Uh,
Hi.
Bye.
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 Bye.